So hello everyone, today we'll be knowing about OS scheduling algorithms. So what are these OS scheduling algorithms? They're very simple. Today we'll be knowing about only one algorithm that's a popular one, round robin algorithm. Okay, this is a very basic OS scheduling algorithm. So yeah. So what OS scheduling exactly is? The algorithm decides which process should take the CPU and for how long. So this is what OS scheduling exactly means. And we have a few definitions here. One is quantum, the time allotted for one operation, or you can say one process on CPU. This is known as quantum. So irrespective of what the operation requires, you assign it some time. If it completes, it completes. Otherwise, the algorithm will decide what to do. But at the end, all the algorithms make the processes complete. Like there's no algorithm that stops the process if time limit has exceeded. And quantum, other thing you should know about is burst time. It's the initial time required by the process to complete. So how does round robin work? Round robin is a very simple algorithm. Round robin is like, let's say you have three processes, A, B, and C. A takes 10 seconds, B takes 4 seconds, C takes 5 seconds. So what are these values? These are, what does the definition say? Initial time required by the process to complete. So A requires 10 seconds, B requires 4 seconds, C requires 5 seconds. So this is burst time. These are burst times. And let's say we have a quantum equal to 3. So how does round robin work is, take a queue, push all of these things here, like A10, B4, C5, successfully pushed all of these. Then pop the front, because you're assigning 3 seconds to it, 3 units of time to it, but it requires 10 units of time. You already gave it 3 units of time. Now how much time does it require? Previously it required 10, you gave it 3. Now it requires 7 seconds of time. Similarly, B requires 1 second of time. Initially it used to require 4 seconds of time. You gave it 3 seconds, it completed whatever the tasks it could complete in those 3 seconds, and it's left with 1 more second. C5. C5 is now left. C is left with 2 seconds now. Let me redraw the queue once again with newer values. A7, B1. Okay, I'm redrawing the queue. This doesn't mean there are two queues or every time a new queue is created. No. Okay. So A7, what's the quantum? How much time are you giving it on CPU? You are giving it 3 seconds on CPU. So now it's left with 4 more seconds to complete the operation. And B1, does it need any time to complete the operation anymore? It needed 1 second. You gave it 3 seconds. It doesn't need more. So you need not push it back to actually check. You can simply do something like printing or returning this thing from here. C2, does it require more time? No. A4, does it require more time? Yes. A4 requires more time. So first B is completed, then C is completed, and finally A1, A is completed. Alright, so this is the round robin algorithm. So if I had to say round robin in a single step, what would I say is, it's very simple. process requires time, push it in the queue. This is the simple thing you need to remember. Now let's write code for the round robin algorithm. I'll be writing C++ as well as the Java code for this. Alright. Now let's say there's a vector of, okay, wait. Let's start it like, let's take a struct process. Process has a name and process has a burst time. I would simply write it as time. Alright. Now let's write void round robin to take a vector of processes and also quantum. So it had a queue, right? Let's take a queue of process. Let's name it in lowercase, more conventional. For process and processes. What's wrong with this? Okay. Should be lowercase one. Yeah. First we'll be pushing all the processes. Q dot push process while Q is not empty. If Q is empty, that means all operations are done. Okay, let's take it as something else. Wait. While true, if Q is empty, that means all processes. Let me see out this. Alright. Now we'll be writing the main logic here. So process current process equal to Q dot front. The current process would always be on the Q dot front. Alright. And you can simply do Q dot pop. You don't need it anymore. Do Q dot pop. Then see, you are assigning like you are allocating some time for it, right? So that time would be deducted. Say you allocated quantum amount of time. You have allocated quantum amount of time. That means that time should be deducted. Now the required time would be time minus quantum amount of time. So let's take current process dot time. The time it requires is equal to, let's take minus equal to quantum. Alright. So if my required time is greater than 0, if it's greater than 0, that means that particular task is still pending. That means it should still be in the queue. Q dot push that particular task with updated time. We have updated the time here. So with updated time, we'll be pushing the same task to the queue. Otherwise, you can do cout task completed. Task with this name completed. All right. and if queue is empty, you just break the loop. Semicolon is missing here. Yeah. So this is it, guys. This is round robin algorithm. Yeah. Let's check if this thing works with a test case. What would be the test case? The previous test case we took. Let's name it uh, files display, some random names. Okay, wait. Let's give it 10, and so this will be giving, let's say, let's name it something like explorer search for and display 5. They should be comma separated. Yeah, fine. Still showing an error. Did we do something wrong? Okay, it's not vector end. My bad. It's vector of process, right? Yeah. Now let's run round robin. Round robin of processes, comma. Quantum, let's take it as 3. The previous example itself. Okay. Try running this. Let's do run code. We forgot to give an endl, so wait. And also here. That's it. Is it the right order? Search completed. Display completed. Yeah, that's the right order we have seen in the example. Search display file. Alright, so this is the round robin algorithm. Let's write the same in Java. Okay, so let's set the Java code for the same. Let's take a static void round robin. Alright, let's take a static void round robin. This would be having a queue. We haven't made the class. Alright, let's call it queue or something. Now what you need to do is first you need to make a class process. So you have a class process with string name, int time, and a constructor. Name comma time. Sorry, it's an array of processes, right? Okay. First you would push everything. Q dot push is the method push. As far as I remember, it's not push, it's add. So add process. Cannot make a static reference to the non-static method add. What's up? Oh yeah. Done. Next. While true. Process. Current process equal to Q dot poll, which would obviously return the front and pop it. So current process dot time equal to minus equal to quantum, and we haven't provided the variable quantum here. Then previously we have done the same. If current process dot time is greater than 0, Q dot add current process, else system dot out dot print ln all processes are done. And once you are done with all the processes, the queue becomes empty. Q dot is empty. Then you should do system dot out dot print ln all processes are done. Okay, sorry for this one. This is not all processes are done. This should be, let's keep it printf process percentiles done, and give it current process dot name. Now let's give some test cases to it. Yeah. So we should also break this loop. So let's try running this code. Term Java is not recognized. Okay, so this needs a backslash n. And I guess that's it. Output is right. We are just trying to format the output now. Search done, display done, file done. The same order. So yeah, it works. So that's it for today. This was the round robin algorithm in C++ as well as Java. So why am I teaching this, or why should you know this? There's one simple reason. In system design interviews, there's a very high chance of these algorithms occurring in any one of the questions. They may twist the problem statement, they may ask you differently, but the underlying algorithm that would actually solve the problem would be these algorithms in some of the questions, not all of them. There are several other algorithms which you need to consider. So yeah, thank you everyone.